During our last class, we looked at the polygon sum conjecture, and we used that in order to figure out the sum of the interior angles today. Today we're going to extend that just a little bit by looking at what we can do with one angle of a regular polygon. So we're looking at the interior angles of regular polygons. So just as a sense of review, we're going to start off talking about the quadrilateral sum conjecture. It's basically said the sum of the four interior angles of any quadrilateral is going to be 360 degrees. Okay. After that, we said if a quadrilateral is regular, okay, so we're dealing with a square, what's the measure of one of those angles? Well, all we're going to do is we're going to basically take that 360 degrees, we're going to divide it by its number of sides. Since a quadrilateral has four sides, we'll just say 360 divided by 4 to say that each of those angles is going to be 90 degrees. Now we can visualize this really well. We can visualize this really well with a square. When it gets to bigger polygons, such as like a pentagon or an octagon or a 17gon, it's going to be a very difficult process. So let's see if we notice any patterns. The sum of the measures of the, so we're talking about the sum again, the sum of the measures of 5 interior angles of a pentagon. Well, the way that we did this, remember, is that we said n minus 2, we subtracted 2 from the number of sides, and we said 180 degrees. So in this case, we'd say 3 times 180, that was 540 degrees. Well, if a pentagon is regular, I mean that's an equilateral and equiangular, then what is the measure of one angle? Well, if there's 5 interior angles, and the sum is 540, shouldn't we just take the 540 degrees and divide it by 5, because there's 5 interior angles? If we do that, we should get somewhere around 108 degrees. Okay, so 108 degrees goes on the line. Okay, in a very similar method, it says the sum of the measures of an n interior angles of an n-gon. That's going to be our formula. That's going to be n minus 2. We're going to multiply that times 180 degrees. Remember, the n minus 2 is what gives you your number of triangles on the inside of your polygon, whatever it is. You're just going to multiply that by 180. Well, if your polygon is regular, what's the measure of one angle? So we're just going to take, we're going to write n minus 2. So whatever that measurement is, whether it's 360 degrees, whether it's 540 degrees, and all we're going to do is we're going to divide it by its number of sides, or n. This turns out to be our formula. We need a formula to figure out the measure of one angle in a regular triangle. There's going to be some key terms that we're going to see. You're going to see one angle. Okay, one angle. You'll see the word one. It'll have to say something about regular in order to use it this way. And something else, instead of sum, we'll see this. Every so often it might use the word each as well. So if you see one, each, or an angle, there's another key term, an angle. So one, an, or each angle. It has to be regular, and again we're talking about interior angles. Okay, so an, one, each, interior, or regular, kind of some key terms. I'll try to formalize this in just a little while as well. So what is the measure of each angle? So we're going to talk about each angle in a regular decagon. Okay, so again, decagon should clue us in that we're talking about a 10-sided polygon. So all we're going to do is we're going to say 10 minus 2, this is our formula, n minus 2. We're going to multiply that by 180 degrees, and we're just going to divide by 10. So 10 minus 2 is 8, so we'll say this is 8 times 180 degrees, and we'll divide that by 10. So 8 times 180 divided by 10, this should give us 144 degrees. Okay, so each interior angle of a regular decagon is going to be 144 degrees. It says, what is the measure of each angle of a regular heptagon? We'll go through a very similar process. All we do is we say that n equals, well, heptagon. Heptagon means 7 sides. Remember, they can say heptagon or septagon. So I'll use the same formula. I'll just say the 7 minus 2. This is to figure out the number of triangles on the inside. The sum of the interior angles of any triangle is 180 degrees. And then to figure out each angle measure Well, let's divide by, well, our number of angles that are on the inside. So 5 times 180, when we divide that by 7, we're not going to get a really nice number. If I round to the nearest tenth, that'd be 128.6 degrees. Is it possible to have 128.6 degrees? As long as it's degrees, I think it's totally fine. If we had an answer that was like n equals 7.6, that wouldn't be a good answer. But our degrees can be have some sort of decimal. Just our n's, our number of sides, can't have any decimal. Okay, well, why don't you guys try the next ones? Just to recall that we are dealing with each angle, we're dealing with regular, and then there's going to give us each specific shape. Take a couple minutes, just try these on your own. Pause the recording now, and when you're ready to check your answers, hit play. Okay, welcome back. We're going to go through these problems really fast. Remember, a hexagon is 6. We'll say 6 minus 2 is 4. 4 times 180 when we divide it by 6 on the bottom here. This should give us 120 degrees. Okay, so that's our answer for this one. The measure of each angle in a regular octagon. Remember, octagon means 8. So we'll say 8 minus 2, that gives us 6. 8 minus 2 is 6. 6 times 180 divided by 8 should give us 135 degrees. So most of these answers came out to be really nice, 120, 135, but it is possible to get some sort of decimal representation for your interior angles. It's totally fine to have that. This is a little bit different. We're going to have to use our brains a little bit more for these types of problems. What it looks like is I try to identify the number of sides. So if I have this shape, this is a quadrilateral. It doesn't necessarily look like a trapezoid. It doesn't really look like a parallelogram or anything else. There's not a lot of properties I can really use. But if I know that this is a quadrilateral, I know that the sum of the interior angles of any quadrilateral, I can calculate that by using this formula. Specifically for a quadrilateral, that'll be 4 minus 2 is 2 times 180, where the interior angles have to add up to 360 degrees. So in case I didn't know that, this is how you would calculate the sum of the interior angles. Then you can write a formula. You can just say x plus 71 plus 135 plus 112 has to equal 360 degrees. At this point, you could add these together. If you just go through, these are each of the four pieces that are inside this quadrilateral. So if you just add them together, you would just get x plus 318 has to equal 360. If you subtract 318 from both sides, you should get x equal to, let's see, the 3's would be gone. This would give us a 4. This would be 2. So x equals 42. So up here, I just want to look at this picture. This is going to be a 42 degree angle up here to make sense. So find the value of x in the diagram, show all your work. Okay. The next problem is going to be pretty similar. It says use the diagram below, find the measure of k, find the measure of L, show your work. First I have to identify, hey, this arc and this arc mean that these two angles are the same. So if I was to label this, I could say this is angle x and this is angle x. They're both the same, so I can say that. Next I use the same formula that I used before, n minus 2 times 180, to figure out the measure of the interior angles. So since I know that this polygon here is a pentagon, which has 5 sides, I could say 5 minus 2 is 3 times 180 degrees. 3 times 180 should give me 540 degrees. So I can say 540 is equal to, and then I'll just add up each of these 5 angles as I go around the triangle, or the pentagon. So I'll say x plus x, which is 2x, plus 68, plus 105, plus 109. Kind of a little note here. If I'm adding the same things together and just saying that's going to be 2x, I could have probably just written that as x plus x as I go around, but I decided to write it as 2x to start off with. So if I add together 68 and 105 and 108, I would end up changing this just a little bit, simplifying, combining like terms. I would have 2x plus 282. I'll subtract 282 from both sides. I'll have 2x on the right side, and using my calculator I would have 258 on this side. When I divide both sides by 2, I just end up with x equaling 129 is my answer. So when I go back up to this this piece here, the measure of angle K, if I was to write this out, the measure of angle K equals 129. The measure of angle L also equals 129 degrees. So maybe that's a good place to write my answers, is right by in the picture where these were at. So I figured out what x was, I'm taking it and I'm putting it back in the formula. Okay, this is our last problem. As we look at this, we know that n equals 4. And sometimes you can go and you can jump and you say, well, hey, this is a quadrilateral. I've done quadrilaterals enough that I know the sum of the interior angles of a quadrilateral is 360 degrees. And what you can do then is you can just add up each of these, each of the angles on the inside here, and I'll just add them up. It doesn't matter whether you go clockwise or counterclockwise around. Just make sure that you get each of the angles on the inside. If I say this is n is 4, I should really have 4 different things here as I'm adding them together. This would be 3x plus, let's see, 155 and 15 would be, this would be 270. So I have 360 equals 3x plus 270. If I subtract 270 from both sides, I would just have 90 over here, or 3x equals 90. I'll divide both sides by 3, and x will equal 30. That tells us that this angle over here is going to be 30 degrees. This angle, 2 times 30 is 60. So this angle over here would be 60 degrees. Okay, this is what we're looking at today. Again, I was able to figure this out from the work that we did yesterday. And really what we're adding is we're adding this whole, this component of it having algebra. So once you know the interior angles, can you use the measures of the interior angles in order to try solving for certain angle lengths? Sometimes that's going to be a quadrilateral or a pentagon, or maybe even more sides, so be careful with that. Then we developed a formula here using kind of word problems that if you ever see the terms each, if you see an, or you see one angle, if it's asking for individuals, if you're talking about interior angles, and if you're talking about regular polygons, we know that these terms specifically go, and then what they do is they refer to this formula, n minus 2 times 180 degrees divided by n. That's what we're really focusing on today. This is the formula we developed at the beginning. Hopefully by now you're able to determine the measure of one angle of a regular polygon. We're able to use algebra to find the interior angle measures. If you ever have any questions, let me know. And I hope you get an opportunity to realize that math is power.